What is cardinality? Simply put, it's all about defining how entities in a database relate to each other numerically. It tells us how many instances of one entity are associated with instances of another. Understanding cardinality is crucial because it helps us create data models that accurately reflect real-world relationships. There are three main types we need to be familiar with: one-to-one, one-to-many, and many-to-many. Each type represents a different kind of relationship between data entities. Even though Power Pivot and Power BI share some similarities, they handle cardinality and relationships differently. Grasping these differences is important for us as business students because it helps us choose the right tool for our data analysis needs and design efficient, accurate data models. Let's talk about how cardinality works in Power Pivot. In this tool, the most common relationships you'll encounter are one-to-many and many-to-one. Usually the one side is a lookup or dimension table. Think of things like customer information, while the many side is a fact table that holds transactional data like sales records. Power Pivot also supports one-to-one relationships, though we don't see them as often. In a one-to-one relationship, each record in one table corresponds to a single unique record in another table. However, when it comes to many-to-many relationships, Power Pivot hits a snag. It doesn't natively support them. So if we need to model such relationships, we have to get creative by using bridge tables or writing complex DAX formulas. This can make our data models more complicated than we'd like. Let's discuss how Power Pivot handles relationship directions. By default, relationships in Power Pivot are single directional. This means that filters flow from the one side of the relationship to the many side. So if we apply a filter to our customer table, it'll affect the related sales records. But if we filter the sales table, it won't impact the customer table. There's no option for bidirectional filtering in Power Pivot. This limitation means we have to plan our data models carefully and sometimes create additional calculations to get the insights we need. Power Pivot works best for simpler data models with clear one-to-many relationships. It's a great tool if we're already comfortable in Excel and want to perform advanced analytics without switching platforms. Now, let's shift our focus to Power BI. Like Power Pivot, Power BI supports one-to-many and many-to-one relationships. It also handles one-to-one relationships when both tables have unique values. The big difference is that Power BI natively supports many-to-many relationships. This feature makes it easier to model complex real-world scenarios without resorting to complicated workarounds. Power BI also allows us to create composite models, where we can mix and match data that's imported or connected live via direct query. When we're setting up relationships in Power BI, we can specify the cardinality as many-to-many and adjust how filters flow between tables. This flexibility helps us build more accurate and efficient data models. When defining relationships in Power BI, you can set the cardinality to many and adjust cross-filtering directions, making it easier to accurately represent the relationships inherent in your data. Let's delve a bit deeper into how Power BI handles relationship directions. In Power BI, we have the option of single directional or bidirectional filtering. Bidirectional filtering means that filters applied to one table can affect related tables in both directions. This is especially handy in many-to-many scenarios where data relationships are more complex. When we create relationships in Power BI, we can choose the cross-filter direction that best suits our needs, either single or both. This flexibility allows us to design data models that can handle more intricate queries and analyses. Power BI is ideal for more complex data models that require advanced relationships. It's a powerful tool for creating enterprise-level reports and dashboards, giving us more control over our data modeling. Let's talk about how we can model many-to-many relationships in both tools. In Power Pivot, since many-to-many relationships aren't natively supported, we have to use workarounds. One common method is creating a bridge table, a middleman that helps connect our two main tables. Alternatively, we might use advanced DAX formulas to mimic the many-to-many behavior. But these solutions can make our models more complex and harder to manage, especially as our data grows. In Power BI, it's much simpler. We can directly set the relationship between two tables as many-to-many. Bidirectional filtering is also available, making our data models more intuitive. However, we still need to design our models carefully. Many-to-many relationships can introduce ambiguities, so it's important to ensure our results remain accurate. Understanding how filters work across tables is essential. In Power Pivot, filtering is single directional. This means if we filter our dimension table, like customers, it will affect our fact table, like sales. But filtering the fact table doesn't impact the dimension table. To get around this, we might need to create extra measures or calculated columns, which can complicate our model. Power BI gives us more flexibility with cross-filtering. We can enable bidirectional filters, allowing filters to flow both ways between tables. This can simplify our data models and make our analyses more straightforward. However, we need to be cautious. If not managed carefully, bidirectional filtering can introduce circular dependencies or affect performance. Performance is a key factor when working with data models. In Power Pivot, we might run into performance issues due to Excel's limitations. Large data sets and complex relationships can slow down calculations and data refresh times, which isn't ideal when we're trying to analyze data efficiently. Power BI, on the other hand, is built to handle large volumes of data. It's optimized for speed, allowing for faster computations and real-time analytics. This makes it a better choice when we're dealing with big data or need more responsive interactions with our data models. Before we wrap up, here are some practical tips for working with Cardinality. Get to know your data. Spend time understanding how your tables relate. Identify your primary keys and foreign keys so you can set up relationships correctly. Choose the right cardinality. Make sure the relationships you define reflect the true nature of your data. Using the wrong cardinality can lead to incorrect results like duplicated or missing data. Use bidirectional filtering wisely. In Power BI, bidirectional filtering can be powerful, but it can also introduce complexity. Be mindful of potential issues like circular references and keep an eye on performance. Test your model. After setting up your relationships, run some sample calculations to make sure everything works as expected. This can help catch problems early on. Document everything. Keep a record of your data model, including the relationships and cardinality settings. Good documentation makes it easier to maintain your model and helps others understand your work. By following these tips, we'll be better equipped to build efficient and accurate data models that meet our analysis needs.